Welcome to AVN Knowledge. Today we will study about the electric current, and topic is small topic, that is the cell, electric motive force, terminal voltage and internal resistance. So generally we use cell, electric motive force and terminal voltage. This is a battery, this is electrolyte, anode and cathode is connected by a external resistance, that is the R, and this is the equivalent diagram of this cell. So here, what is the cell? What is the cell? Cell is a equipment that converts chemical energy the basic concept is, and how get the chemical energy we use in different type of battery, different type Wanda battery, lead acid battery. So we can use this electrolyte may be different. So here the basic concept is electric energy is get by the cell, that is the chemical energy, and chemical energy convert to the electric energy, that is called the cell. And what is the electric motive force? This is denoted by also, and terminal voltage is denoted by V. The basic difference between electric modifier and terminal voltage, the unit is same. This is not force. Unit is volt. So generally student, electric motive force EMF, that unit is also volt. Terminal voltage also we use the voltage, unit is volt. What is the basic definition of electric motive force? The basic definition that electric motive force is used in open or closed circuit. So where we use the open circuit. What is the open circuit and what is the closed circuit? This battery terminal, when external resistance capital R is not connected, that is the open, and this is the terminal T1 and T2. This is not connected by the external resistance. So the potential difference between open circuit, the external resistance R is not connected, this is not connected, and the potential difference between this terminal T1 and this terminal T2, the potential difference between T1 and T2 when external resistance is not connected, that is the open circuit. In this condition, the potential difference between two terminals is called by the electric motive force. So when we use the electric motive force or EMF use in open circuit. When the open circuit, external resistance is not connected. So the definition is also the potential difference between two terminals in open circuit, or we can say external resistance is not connected in this battery, that is called by the EMF of this cell. In closed circuit, when external resistance R is connected, this cell, that is closed circuit, and the potential difference between T1 and T2 when in closed circuit, that is called the terminal voltage. So basic difference in closed circuit, the potential difference between T1 and T2, that will be the terminal voltage. In open circuit, the potential difference between T1 and T2 is called the EMF of the cell. So the basic difference, that is open circuit EMF or closed circuit terminal voltage, both are the potential difference and both unit is volt, dimension and unit already we have proved. So this is the basic definition of EMF and terminal voltage. And in physics lab, generally external examiner asks what is the difference between the electric motive force EMF or terminal voltage, what is the unit. And when we generally in physics lab do the experiment of the potentiometer, external generally ask what is the difference between EMF or terminal voltage. So this is the basic difference of EMF or terminal voltage. Here a unit is also, that is the internal resistance, and generally we use for the internal resistance is smaller. What is the internal resistance? Resistance is same. Resist of the molecules or the cation or positive ions or negative ions. So here molecules or charge move from here to here, anode to cathode or cathode to anode. The resistance between these ions in the electrolyte, that is called the internal resistance. Internal resistance is also resistance, but this resistance in electrolyte or in cell, when the ions move from electrode to cathode to anode or anode to cathode, this resistance is called the internal resistance. Unit is same, that is the ohm. Dimension is same for the resistance. So what is the difference between internal resistance and external resistance? External resistance we use in a conductor and used in outside circuit, and internal resistance generally the internal resistance of the cell. And here what is the relation between EMF, internal voltage, terminal voltage, internal resistance? So here we derive the relation between terminal voltage EMF or internal resistance of cell, E minus V. E is the open circuit voltage, V is the potential difference between closed circuit, that will be the I into R. So here this is the equation first. This is the difference in open circuit, in closed circuit this is the potential difference. You can say I into R. R is the internal resistance of cell. So here by the Ohm's law, V equal to I into R. The potential, if current is I, current resistance is R, you can write V equal to IR by the Ohm's law. Put the value of V in this equation, E minus IR equal to I into R. So E equal to IR plus R. So here I equal to E upon R plus R. This is the current flow in this cell, that is the I equal to E upon R plus R. What is the formula of internal resistance? Internal resistance, you can write E minus V upon I from this equation. This is the internal resistance. And what is the I? You can write I from this equation, R equal to E minus V, V upon R, or you can say R equal to E minus V upon V into this is the internal resistance of cell. Unit dimension is same as the resistance. So this is the current flow in this cell and this is the internal resistance of this cell. The major factor, what is the major factor? Major factor of internal resistance, that is R is proportional CID upon A into T. So here when we use the internal resistance, what is the C? C is the concentration of this electrolyte. C is the concentration of this electrolyte is proportional to the resistance. When we increase the concentration of electrolyte, increase the internal resistance. So first thing is concentration of electrolyte increase the internal resistance of the cell. Second is current. When we increase the current, the internal resistance is also increased. Third is distance between electroplate. You can say this distance, that is the D. When we vary the electrolyte plate from increasing the distance or decreasing the distance, this distance between cathode or anode plate is also depends on the internal resistance. When you increase the distance, increase the resistance. When decrease the distance, decrease the distance. So fourth is area of the plate is inversely proportional to the internal resistance. This positive or negative cathode or anode plate area also depend on the internal resistance. And this is the temperature. When you increase the temperature, decrease the internal resistance. So this is the basic major factor that depend on the internal resistance. Here, what will be the internal resistance? Internal resistance is depends on these factors, and when we use the current from the cell, it means the current flow outside the circuit. When you use the vice versa means V minus E equal to I into R. In which condition? When cell is charged. When cell is charged. When cell is charged means the current is flow in the cell. So here V minus E equal to IR. When current flow in the outside circuit, then E minus V equal to IR. This is the basic concept of cell. So when we use this terminology in series combination or parallel combination, then we use this formula. The current flow in the outside circuit or current flow in inside circuit. Inside circuit when cell is charged, and when cell is flow the current in outside circuit. So this is the basic concept of this terminology. So kindly subscribe this channel. If you have any doubt or any comment, kindly comment on this channel. Thank you.